All right, Jossie. So, have a look at your wee sample here. So, I've got the bag here. This is the northeast bed number 4. So this is the cover crop one. I thought this might be the most interesting because it's had some plant growth on the top. So this is times 40 magnification, 40 times what your naked eyes can see, basically. So we'll just have a little bit of a scan here. This little interesting coiled spring thing here in the very center is a piece of plant cellulose. Not unsurprising to find that, as you'd imagine. So we will zoom in further to pick out more detail. This thing here looks to be a piece of plant debris as well, just busted around. What else have we got here? All these little, the tiny little specks that you can see are some form of mineral, basically nutrients, or waiting to be nutrients, effectively. So this is just sort of raw geology. And then the darker, larger specks will be aggregates. So that's a result of biological action those are forming. Forming them all with their glues, of course. This is another bit of plant detritus here. So at this magnification, we're really looking for nematodes and macroarthropods. We'll see bacteria and all the fun things when we zoom in. Not that nematodes aren't fun, but we really want to see nematodes because they're a big part of the nutrient cycling interaction. This strand here, I'm going to zoom in a bit further on that one because it possibly is a fungal strand. So let's go to 100 times magnification. And I just have to focus with my microscope. The microscope and the camera are not the same planes of focus, so it's a bit awkward. So yeah, this thing here is an aggregate, and we can tell it's like fulvic acid probably because of its honey-coloured appearance. You can see at the edges there, and the darker bits in the middle are probably not humic acid. Humic acid does have a darker appearance, but I think it's just because the light can't penetrate all the way through, so it appears shadowed basically. So this little filamentous thing is what are you? Certainly not a fungi, or at least not a beneficial fungi. There's a fungal spore at the bottom here. So that little dark shape in the middle, the oval shaped thing with the circle in the center, that's a fungal spore. Good sign there. So we'll just have a little brief scan around, see if we can see anything moving. Not much moving so far. This is more plant material or root hairs. So protists, basically, the things that are always missing from soils that are in sort of poor condition, are generally the protists and the nematodes. So the higher trophic level of predators, which are completely required for there to be adequate nutrient cycling in order for your plant to be really healthy. So the growth of the plants can be explained. It can be explained to some extent because if there's been a great disturbance in a fairly undisturbed soil, then a lot of these species of bacteria and protists will die and release their nutrients into the soil in a plant available form. But we're really looking for this nutrient cycling to be happening passively, as it were, as in there's no input required from us apart from our apart from our general management, for the longevity of the market garden. So let's just have a little zoom in here. It's going to go out of focus for you. Right. So this is times 400. So this little strand in the center here is one of your actinobacteria pals. here. There we go. It's a bit refractive, I'm afraid. It's just that's picking up on the camera lens. So yeah, this is a strand of actinobacteria. It's individual bacteria that make a casing for themselves that looks like a hyphae, a fungal hyphae. So yeah, like I was saying before, a bit of an indicator of fluctuating oxygen conditions. They possess basically, obligate anaerobes possess a single type of enzymes which are most effective in low oxygen conditions, which means that they can outcompete the obligate anaerobes whose enzymes become less effective in lower oxygen conditions, and then the facultative organisms can produce both sets of enzymes for either condition, and so they outcompete the two extremes when the oxygen conditions are fluctuating. So that is one of them for sure. These little things that are moving around, you probably guessed it, those are in fact bacteria. Anything that's rounded is a cocci. Anything that's rod-shaped is a bacillus. Anything that's a bit of a hybrid of the two is a cocobacillus, which I love the name of that. I think that's cool. This is a good fulvic acid here. Another little strand. Looks to be a fungi of some description. Let me just have a look at it on the microscope. It looks to be a fungi of some description because there are cross walls that you can just about make out the division of the fungal cells. So after the fungi has grown a cell's width, it lays down a cross wall. But it looks to be not very beneficial. Firstly, it's glassy white, which is a bad sign. It means it's not producing those organic acids that we're looking for. And it's very, very, very narrow in diameter. So one single one of these little cocci bacillus that you can cocci that are gyrating around beside this fungi are about 1 micrometer across. So you can see if you compare the cocci to the width diameter of the fungi here, you won't be able to make it out, but I can tell that it's no more than 1 to 1.5 micrometers in diameter. So neither of those things are particularly good indicators. Okay, so let's keep having a wee scan. All these little transparent things that have sharp, jagged edges are not organisms, they're all minerals, like I was saying before. So there'll be your sand, silts and clays, silica. You can see a lot of silica around here. As you would expect, because we know there's a beach under here. And we're right beside the sea. Like there's a big bit of silica right in the centre there. That's just a piece of glass, essentially. So lots of bacteria, as I would expect. This is all pretty as much as I would expect it to be. Very bacterially dominated. The other thing that we're looking for are cysts. Basically, when predators have gone dormant, they can when the conditions don't favour them, they can create cysts, which allows them to, survive the bad times. So that little round ball there, right in the centre.